All right, welcome to the first video of pre-calculus. This is section 1.1 part 1, and we're going to actually learn about this term called functions. Functions are very important, especially when you go into calculus and the higher maths. You've got to know what a function is. And the essential question of what we're going to learn in this section: what are functions and how do they work? Okay, pretty short and easy question, but at the end, hopefully that's what we understand what we're going to do. All right, so what are we going to learn? Part 1, there's two parts of this section. Part 1, we are going to describe the subsets of real numbers, so the sets of real numbers that are smaller and more narrow. And we're going to learn part 2, how to identify what a function looks like. Okay, and you actually probably talked about this in Algebra 1, but we're going to get into this a little more in depth in pre-calc. Okay, so let's get started. Part 1, describing subsets of real numbers. All right. So the first thing we need to talk about is real numbers. What are real numbers? All right. Real numbers are any number. So any number you can think of, that's a real number. Okay, they're the most broad. It encompasses any single number that you can think of is a real number. Okay, and then this picture on the left here, we're going to use to show all the different subsets of numbers. Now the circle's inside the real number box. So any number that's inside this box is considered a real number. Okay, and then a circle that's inside of another circle is considered that topic as well. So let's look at this very first circle. The first circle we're going to come to is Q, and Q stands for rational numbers. Okay, and rational numbers are any number that can be written as a fraction. So 2/3, 1/2, 0.6, 0.125. So decimals that stop. Decimals that stop are considered rational numbers. Any of these numbers can be written as a fraction. Okay, 4/3. Any of these numbers are considered rational numbers. All right, so that's the first circle. The second circle is letter Z, and that stands for integers. Okay, why doesn't integers start with I? We already have something else that starts with I, so we're going to use Z for integers. And what are integers? Integers are all negative and positive whole numbers. So -3, -2, -1, includes 0, 1, 2. So all your counting numbers, but it includes negatives and positives. And you can put dots here, meaning that goes on forever both directions. Okay, so those are integers. All right. Then we have our next circle is W, and that stands for whole numbers. Okay, whole numbers are counting numbers, but it just starts at 0. So 0, 1, 2, 3, 4, 5, and so on. Now, what is the difference in integers and wholes? Well, wholes are smaller because they don't include any of the negative numbers. Okay, so they're counting numbers that don't include negative numbers, but it does include 0. Okay, and then the last circle in this middle are your N, and that stands for natural numbers. And I'm sure you've talked about this at some point, but it's good to remind yourselves about some things. And natural numbers are almost like wholes, but it gets rid of the 0. So 1, 2, 3, 4, 5, and so on. All right. So each one gets more and more condensed in what it actually contains. And then we have this oddball here, I. Okay, this is the I section. Okay, what does I stand for? I stands for irrational numbers. And those are any numbers that cannot be written as a fraction. So for instance, square root of 3 is equal to 1.732005. And I think there's actually more, but notice that can't be written as in the form of a fraction. So those are called irrational numbers. Okay, so we're gonna refer back to this chart, but hopefully this makes sense. So anything that's inside of the rational circle, which includes integers, whole, and natural, are also considered rational numbers. Irrational is completely on its own. It doesn't include anything else, but it is real numbers because real numbers are any number at all. All right. So we need to learn how to do a set builder notation. Okay, what does that mean? It means it describes sets of numbers. So notice we have this little kind of squiggly arrow thing. I'm gonna create a set of numbers. I'm gonna say -2, -1, 0, 1, 2, 3, 4, 5. I'm gonna go to 6. And I'm gonna close my set. So these braces mean sets, and we'll talk more about that later. All right, we need to know how we can describe what we're looking at here. Okay, so we're going to describe this. Anytime we have a set, we usually just use x. Okay, so we're going to describe this. All x values. And then you have to tell what set of numbers this is in. These are counting numbers. It includes positives, 0, and negatives. So which one of our numbers includes zeros, positives, negatives? And I see that it's z. What does z stand for? Integers. Okay. So we have this, and we're going to do x is in the set of integers. And now we have to describe where our numbers are located. Okay, what number does it go to and from and to? It goes all the way from -2 to 6. Okay, so we're going to use inequalities. The numbers go from -2 to 6, and I'm going to close my set. Now, what do we have to put in between here? So we're talking about x's. That's typically the variable that we choose. And we're going to do that it's between -2 and 6. Doesn't include -2 and 6. Yep, it does. That's why I put the line underneath it. So how do I read this? We read this from the inside out. So x is less than or equal to 6. So 6 is the biggest, everything less than. And x is bigger than or equal to -2. So it starts at -2 and it's everything bigger than. And it's only including integers, the z's. All right. How do I know that? Because that's what the numbers are included. -1, -2, 0, 1. Those are only the integers. So we have to say what kind of numbers they are and then how we get to them. All right. So let's talk a little bit about this set building. So this is your final answer here. Okay. This means, the first part means the set of numbers. The set of numbers x. Okay, so you're just telling you what variable we're going to use. Okay, and x, the x is in, so this e means element. X is an element in the set of integers. Okay, so that's that part. And then the third part, okay, that we're always going to talk about is, what does this mean? X has the given properties. Okay, so what are the properties? Well, the property is that the numbers go from -2 to 6 and includes the numbers in between, but only the integers that are in between. Okay, so this will make more sense when we do a few more examples. So let's look more at how we do the set building. All right, so here we go. We have the example. 1, 2, 3, 4, 5, and the dots mean that it's going to keep going like that. 6, 7, 8, 9, 10. Okay, so let's build our set. Okay, that means set. We're talking about the sets of x numbers, and what set are we going to be looking at? Are we looking at q's, i's? Now, this starts with 1, okay? It doesn't start with 0. All right, so let's look here. What numbers start with 1? Okay, it looks like n, and it goes 1, 2, 3, 4, 5. Okay, so we're going to be in the natural numbers. Okay, and describe how every number bigger than what? It goes from 1 to 5, and it keeps going on forever and ever and ever. So the numbers are x is greater than or equal to 1. Now, why don't I have it doesn't tell me where I need to stop. The last one, it went to 6 and it stopped. It didn't have any dots, so it doesn't go any further than 6. This one, it keeps going. The comma, dot, dot, dot means it keeps going. So it's all numbers bigger than 1, and we're talking about natural numbers, so 6, 7, 8, 9, 10. Okay, so this is a little confusing at first. So let me slide this one over. Okay, let's do the next one here. Okay, it says x is less than 7. X is less than 7. All right. So what do we think about this one? All right. So we have to start our set. I need my pen. Okay, we're still talking about x. All right. Now, what set are we in? Now, it doesn't tell us. It just says the numbers that are less than 7. If it doesn't tell you what set you're going to be in, you're going to assume that we are in the real numbers. All right, we're going to assume that we're in the real numbers. Now we just have to describe where the numbers are located. Well, this one's kind of nice. It tells us it's everything less than 7. So x is less than 7, close your set. There we go. So that one's kind of nice. All right, so that's example A and B. All right, so I'm going to get rid of these since we don't need these anymore. I should have gotten rid of those in the first place. And let's look at C now. All multiples of 3. Okay, so this one's fairly tough. Okay, so we're talking about all multiples of 3. So let's start our set here. So build my first brace. These are called braces. All right, we're still talking about x. Now all multiples of 3. So let's start 3, 6, 9, 12. Now what about -3, -6, -9? Those are also multiples of 3. They're just in the negative direction. So which numbers include negatives and positives? Okay, so which one of our sets of numbers includes negatives and positives? Okay, so hopefully you see that -3, positives, those are the integers. Z stands for integers. So that's the set we're going to be in. We're going to be in integers. So x is an element of our integers. And then how do I describe multiples of 3? This one's pretty tough. So x is equal to 3 times n. Okay, so 3, think of n being any number. What's 3 times 1? 3. 3 times 2, 6. 3 times 4, 12. 3 times 5 is 15. 3 times -1, -3. 3 times 0 is 0. Okay, so that's describing multiples of a number. X equals 3 times some number. Okay. All right, so one more to do here for set building notation. This is pretty tough. It's not easy stuff. We'll talk more about them in class as well. All right, so here we go. So this one goes from 8 to 11. Okay, and it keeps going on and on. That's what the dots mean. So x numbers. What set are we in? Counting numbers, 8, 9, 10, 11. So we're going to do naturals again, just like that one. And let's see here. And we don't know it includes 0. So I'm not going to put whole numbers because I don't have any idea if it includes 0. So we're just going to do natural numbers. So it starts at 8 and it goes on forever. So what should I write? X is greater than or equal to 8 because it includes 8. 8's the first number. All right. And this one we had greater than 1 because it does include 1. And this one we have no idea what the numbers are, so they're real numbers, and x is less than 7. I don't need the line underneath there. Okay, so that's set building notation. All right, the second type of notation we need to talk about is interval notation. So you can do the same thing. We can use set building, and we can also do interval. Okay, so we have two types of interval notations here. The first one is this one right here. These are called brackets. Okay, and what do brackets mean? Brackets mean that the numbers are included. And this will make a lot more sense when we do some examples. Okay, so then the next one are parentheses. Oops, forgot the H. Hopefully, and this means not included. Hopefully I spelled parentheses right. Not a big deal if I don't. And then we have these two new things over here. It looks like a sideways 8, but this actually means infinity. Okay, and this actually means positive infinity. And that one on the left means negative infinity. So the top one means really, really, really big, going on forever and ever and ever and ever. This one means negative infinity means really, really, really small, going on forever and ever and ever in the small direction. And both of these mean unbounded, meaning we don't know when it stops. Okay. So let's look at some examples of interval notation. All right, so how this is a little bit easier than the set one. Write each set of numbers using interval notation. All right, so okay, so let's read what this says. Let's read the right part here. It says x is less than or equal to 16. Okay, does it include 16? Yes, because of the line. So I'm going to do the included. Okay, remember brackets mean included. If it says equal to, you know it's got to be included. Okay, I'm going to put a comma, and then my other number is -8. Now, what does it say on the other side of this? It says x is bigger than -8. It doesn't say bigger than or equal to or greater than or equal to. It just says bigger than 8. So I'm going to use a parenthesis because it doesn't say it's equal to. There's no equal to symbol. Okay. So this tells us that the numbers go from -8 to 16, but does not include -8. All right. So let's look at the next one. So the next one says x is less than 11. So I'm going to put 11, and do I need a parenthesis? Is there an equal sign? Nope, there isn't. So I'm going to put a parenthesis around 11, and it says numbers less than 11. Does it tell us where we're going to stop? So numbers smaller than 11 are going to the left on a number line. So here's 11, and it's everywhere to the left of 11 because it says x is smaller than 11. So we don't have any idea where it's going to stop to the left. So I'm going to use negative infinity because I have no idea where it stops. So this tells us that our numbers are going to go from negative infinity to 11. Okay, hopefully that makes a little bit of sense. All right, let's try the next one. All right, so let's see what this one says. This one says x is less than or equal to negative 16, or x is greater than 5. So when there's the or here, we have to do each one of these separate. So we need two separate ones. All right, so I'm going to do negative 16 first, and I'm going to put a bracket because it says less than or equal to, so I need a bracket around the 16. And then what are we going to put on the left? It says x is less than negative 16. So do we know where it stops going to left? We don't. So it's going to go negative infinity. And now those always are open. Those are not included. And then we need to do another one. And we're going to do this. This U means that these are together. We need to put these in one. That means union. Okay? And it says x is greater than 5. So now 5 is the small number, not included because no equal sign. And we're going to go greater than 5 to positive infinity. Okay? So 5 comma infinity. Okay? And once again, that's not. All right, last example here we have, it says negative 3. So it says x is between 0 and negative 3. So it's between. So equal to symbol on the right. So I'm going to have a bracket. Not an equal to symbol on the left. So I need a parenthesis. And it goes from negative 3 to 0. So the numbers go from negative 3 to 0. Does not include negative 3 because of no equal sign, but it does include 0 because it has an equal sign. Okay. So we'll do more examples of those too. So but that's a little bit challenging. So we'll talk more about that. Hopefully that makes some sense. All right. So part 2, identifying functions. Identifying functions. How do we know if something is a function? All right. So there are two types. The first type is called a relation, and it's a rule that relates two quantities. And the rule is that any input can have any number of outputs. Okay. So what does that mean? So any number. Any input, so numbers that go in are typically x's, and numbers that come out are usually y's. It says any input can have any number of outputs. So what does that mean? That means if I throw in a 4 in my machine, I could get a 5 and a 6 out, and that's okay. I could throw in a negative 2, and an 8, a 14, and a 16 could come out. That's okay for relations. Okay. Functions are what we're talking about. Functions are a little more important. Okay, a function is a special type of relation, and every input can have only one output. Okay, so for instance, let's say we're talking about the function y equals x plus 2. All right, so if I throw in, remember x's are inputs, y's are outputs. Let's say I throw in the number 3. So 3 goes in my machine. 3 plus 2 is 5. Okay, so that's my only answer for that problem. All right, now, what happens if I throw in 6? 6 goes in my machine. 6 plus 2 is 8. Is there any other answer for this function that if I throw in a 6, I'll get something else than 6 plus 2 equaling to 8? I don't think so. I think that's the only answer. So that is the definition of function. Every input can have only one output. All right, so let's look at this example. Here's a machine. It says I throw in 1, I get 6. I throw in 2, I get 8. I throw in 3, I also get 8. And if I throw in 4, I get 9. Does every input go to only one output? Every input goes to 1. It's okay that these two go the same as long as they only have 1. So yes, it is a function. Okay. Now we have these two new words called domain and range. Domain are always your x or your inputs. Okay, so what are my inputs? My inputs are 1, 2, 3, and 4. 1, 2, 3, and 4. Okay, so there's my set of my inputs. Range are all your y values or your outputs. Okay, so what are my outputs? What numbers did I get out of the machine? Now 6, 7, 8, 9 are here, but which ones actually have an arrow? The 6, the 8, and the 9. You don't have to list 8 twice. It's just 6, 8, and 9. So there is the range of my function. Okay, so example 3. Are the following organizers functions? So does every input only have one output? Okay, remember x's are input. So -2, 4, 3, -1, 3 goes to 4, 5 goes to 6, 7 goes to 9. Does every input have only one output? And for this one, I'm going to say no. So this one is not a function. Why? Because 3 goes to 2 different answers. 3 goes to -1 and 4. Can't happen. So not a function. All right, let's look at B. Does every input have only one output? -2, 4, 6, 3, 7, 2, 8, 1. Does every input have only one output? Yes. So it is a function. All right, so let's look at C. This one's a little bit tougher because it's a graph. Does every input, so remember, inputs are x values, outputs are y values. Does every x value have only one y value? So if I put my pen here and I go up, it only touches the graph one time. One time. Touches the graph once. So basically what you can do is you can do a vertical line test. What does that mean? Vertical line test. So let me draw a vertical line. And if you drag your vertical line across your graph, as long as it only touches that red line once at a time, it is a function. Okay, so it's passing the vertical line test. So yes, this one is a function. Okay, let's go to the next page. So let me cut this out. All right, let's look at the next one. All right, so is this circle a function? Does it only touch my vertical line once at a time? And if you notice, if I put it right here, how many times does it touch? It touches once here and once here. Automatically not a function. So no, not a function. Okay, hopefully that makes sense. All right, and the last one, let's look here. Here's a verbal one, if we can describe if this is a function. So your inputs are student ID numbers. Every student has one ID number. The outputs are student score on the physics exam. So how many exam scores is every student ID going to take? How many times does every kid take a test? Hopefully once. How many scores are you going to have on that test? Hopefully one. So every ID has one exam score. So yes, it is a function. Every input ID number has only one output and exam score. Okay, so hopefully that makes some sense. All right, that finishes up. That's the introduction to functions. We will talk more about this in class. I'll answer any questions. I will see you tomorrow.